In Lesson 3.4, we're going to be looking at arithmetic sequences and how they relate to a linear function. So you'll see a list of numbers here on example 1, and we can notice what's happening between each of them. If you look carefully, every time we're adding 13 to the next number in the sequence. Now you may be wondering what a sequence is. It's just a list of numbers. The term of the sequence is which specific value you're referencing. So we would say maybe 26 is the first term of our sequence. Now noticing that they increase by 13 each time, this is definitely referred to as an arithmetic sequence. Arithmetic sequences are a list of numbers that are obtained by adding on the same amount to the previous number each time to get the next number. So because each number is 13 more than the previous one, we're adding the same amount between each term in the sequence. So it is arithmetic. We would say our first term in the sequence is 26. Our second term in the sequence is 39. Also, another notation is called subscript notation. The tiny little number below, this means the first term of your sequence, 26. The second term is 39, and so on. One last vocabulary term to note is a common difference. That's how much it is between the first term and the second term, or the second term and the third term. What is your sequence changing by? It may be important to note that your common difference can be both positive or negative, depending on if your sequence is increasing or decreasing. So when it comes to terms, there are some formulas we can make. And a recursive formula has to do with these subscripts. So if we call our first term a sub 1, our nth term could be called a sub n. We get any term we want by adding the previous term plus the difference. So in our last case, we were adding 13 on to every number before it to get to the next number. This a sub n minus 1 means the term before the nth term. So if I said a sub 8, that's my 8th term, this would mean take my 7th term and add 13 to it in the first example. In just practicing this, if someone gave me my 2nd term, my previous term would have been my first term. Or if my previous term was the 7th term, my next term would be the 8th term. You could fill out all of these just recognizing that the term before and the term you're on can be notated by your subscript notation. So when it comes to making formulas, if we look at writing a recursive formula for the days you've rented a bike. So note we rented a bike for 1 day, it costs 26. For 2 days is 28. For 3 days is 50. This is a new relation, and every day we rent the bike, it costs us, if we find the difference between 26 and 38, it costs us another $12. So it's $12 more every day to rent the bike. Our difference then is 12. That means we're adding 12, a positive 12 to each term from the previous. If they ever wanted us to write a recursive formula, so in the previous page we saw a recursive formula would say, give me your first term, always tell me the first term. So in this case, my a sub 1 is 26. For 1 day, it would cost $26. Then they would want, if you want to get any day that you want to rent the bike, say day 8, you would need to know day 7's information and add the amount on for each new day's rental. So in our case, we would say a sub n, any number of days you want to rent the bike, would be equal to the amount it was to rent the day before, plus 12. Now recursive formulas are not super helpful, because if I decide I'm going on a 30-day bike trip, I would need to know how much it costs to rent for 29 days first before I can find day 30's rental price. That is, I would need to know each previous day to add 12. So it would just be more of a making a table all the way out till the number of days I want to rent the bike. But when it comes to an explicit formula, this is a little more helpful. They say if you want to know, say for example, on the 12th day, how much money it will cost to rent the bike, you can do your original first day amount plus the number of days minus 1 times the difference. Let's give it a try. Let's look at our table up here. Let's say I didn't know how much it cost to rent for 4 days. This one says I would take my first day's rental cost, which is 26, plus n minus 1, 4 days minus 1, times my difference, which is 12. By completing the math, I'd have 26 plus 3 times 12, and that's 26 plus 36, and that would give me 62. Here I can see that that really is the amount of money it would cost to rent for 4 days. This explicit formula allows someone to just plug in n number of days they want to rent the bike and find the exact amount, which is much more helpful than that recursive formula. So, if we were going to make an explicit formula in general for our bike riding, we would say a sub n equals my first term, which is $26 for the first day of renting, plus n minus 1 times my difference in each day, which is 12. Now, one little side note here. Your teacher may focus on this a little bit. Remember when we had the y equals mx plus b equation? M was the change or the growth in each point. Our b was the beginning value. If I wanted to make this look more like an equation with slope equals mx plus b, I could multiply my 12 through, and I'd have 26 plus 12n minus 12. And then 26 take away 12. Give me 14. This is another recursive formula. And think about it here. Oh, this would be a positive 14, sorry. 26 take away 12. This means if I didn't rent the bike at all, it would cost $14, which is a little weird because we don't usually just pick up a bike for don't pick up a bike for $14. But it is possible to make it look like a slope-intercept form when you're creating an explicit formula. Now, if someone wants to know how much it will cost to rent the bike for 10 days, we can plug in our 10. So I could take either of these equations. I'll take the original. If I want to go for 10 days, I do 26 plus 10 minus 1 times 12. We would have $134 for a $10 bicycle renting. Now, how is this explicit formula related to the arithmetic sequence and a linear function? Remember, this 12 is like your slope. It's what it's growing by every time. Your 26 is somewhat like your start value, but that's actually on day 1. So if we were to ever look at a graph of this, I would say on day 1, for 1 day, it would cost me $26. For 2, it would be $38. For 3, it would be $50, and so on. You can see how this linear equation is forming. And each time it's going up by $12 over for 1 day. We just had to work backwards a little bit to think of what it would be on day 0 to see that y-intercept come into play, and that was our 14 that we got when we solved using that distributive property. So again, we can see the explicit formula has that growth or slope with our difference. So the difference is like our slope, and our y-intercept is kind of like our 0, our x equals 0 spot. We just have to go back a day. Just to start, one more quick example. This one has a $2 per day rental, so we can see that that's our difference. It's growing by $2. And the cost to rent a bike is $28 for the first day, so that's our a sub 1. To give an explicit formula for n days, we would say any number of days would be your first day amount, plus n minus 1 times the difference. Another way to think of that could be 2n plus 26. That's because when you take your 2 times n, you get 2n. And 2 times negative 1 makes negative 2 from 28 makes 26. This would actually be like your 0-day rental, like your y-intercept. If they want to know how much it costs to rent it for 8 days, you just plug your 8 in wherever you see the n on either equation. For a recursive formula, we want to be able to think of what happened to my previous number to get to my next number. Remember, recursive is not quite as helpful. So if I'm given an explicit formula, I know this is like my slope. It's kind of like by my mx situation. This is my difference. This is what each term is growing by. And this is my day 0, or my n equals 0 value. So I would know my a sub 0 equals 8. My difference is 3. So if I ever want to get my next term, I will take my previous term, my a sub n minus 1, and add 3 to it, starting at my 0th term of 8. Now you could also say your first term will be 11. Sometimes they like to give the a sub 1. Over here, my difference is a negative 5. So that means if I want to get the next term, I would take my previous term and subtract 5. And here this tells me my start, or my 0th term. So I could say a sub 0 equals 12, or I could say a sub 1 is 7, because I would be 5 down from there. Both of those would be your recursive formulas.